Alright, hello again. This is Jeff Scott of Blackhawk Technical College. We've been going over the first 17 chapters of iOS 9 App Development Essentials for the 152-153 Mobile Web Development iOS class for the spring 2016 semester. I've done the first 10 chapters, and now it's time to go into Chapter 11, which in many ways has got a lot of, it's got code in it, but in many ways it has a lot of stuff that you've already heard in other classes in it. You know, the basics of object-oriented programming. Swift is an object-oriented programming language. All right, and as we see when we start looking here, you know, he's got some definitions. What is an object? An object is also referred to as an instance. It's a self-contained module that contains both data, which is known as properties or attributes, and functions, which are typically known as methods or sometimes as behaviors. A class, as he mentions there, is a blueprint. It defines what objects of that type of class will look like. So it defines what the methods will do and what the properties will be. All right. Before you can create an object, you need to define the class or blueprint for the object. So in this chapter, they're going to create a bank account class to start to demonstrate some of the basic concepts of object-oriented programming. And since it's a Swift class, it will be Swift OOP. All right, so they show you down here near the bottom of the page what the syntax for this will look like. So in other words, it's class followed by the name of the class, and if the class extends or inherits from another class, that's how you do it in this language. You don't use the word extends. You use, after the new class name, you use a colon and then the name of the parent class. Then you have your properties and your methods, your instance and your type methods, and we'll talk about what all those are as we go on in here. All right? So the first thing that we're told to do is we're told to come in and start creating a brand new class. So let's go in and do that. All right? And I'm not sure if I'm going to be able to do this inside of, as I have been doing here, inside of a playground. So what I'm going to do instead is I'm going to do a file. I'm going to save. I'm going to do another file. And I want to close my playground. All right, so I'm still inside of Xcode, but I want to close my program, my playground, I should say. Now what I'm going to do is I'm going to start up a new project. All right, and as I come in here, I'm going to create a new Xcode project. And we'll keep it as a single view that really and truly for what we're doing, I don't think this is going to matter too much. And we're going to call this, how about bank account example. And all this stuff that's here, I'm just going to leave it the way that it is. Swift, I can make it universal. It really doesn't matter. I'm not using core data yet, so I can click next. But I'm going to do something a little bit different here once this gets up. I want to save this onto the desktop. It's already there. That's good. So create. But now I'm going to do something that I don't think, at least, you've seen me do before. And that is, I'm going to come in, I'm going to do a file, and I'm going to do a new, and I'm going to choose File, New File. And I want Cocoa Touch class there. That's what I want. And I'm going to click Next. Okay? Now, what I'm asked in here is what I want to do. This subclass of this, etc. Well, let's go back one and let's take a look and make sure. Let's see what's in here. Objective-C file, header file. I believe it is a Cocoa Touch class. That already should be underneath here. And it's not a user interface, so I think, nope, it's not there, or there, or there, or there, or there, so it must be this one. All right, so I'm going to say Cocoa Touch class. I'm going to click Next, and I'll keep it, the name of the class I'm going to put in here is bank account. And a subclass of, not really sure, so I'm just going to leave it the way it is, which is the default, and I'm going to click Next. All right, where do you want to save it? Well, I want to save it in with my other stuff, my bank account example, so I'm going to click Create. And that gave me a new class right here. All right, so class bank account. Now, I'm going to remove everything that's in here, so it just looks right now like this. All right, and I'm going to start keying in the stuff that they put in the book here. So the first thing I'm going to do is I'm going to add some instance properties. So every time I create an instance of a bank account, it's going to have an account balance, which I'm going to make a float, and I'm going to set it equal to 0. And it's going to have an account number. And I'm going to make that an int, and I'm also going to set that equal to 0. So again, what I've just done is I've shown the concept of data encapsulation. The idea behind that is that data should be stored within a class, which is what this is, and it should only be accessed through methods which we're going to define in the class itself. Data that you encapsulate or store inside of a class are referred to as either properties or as instance variables. So each time we create an instance of a bank account, that particular bank account object that we create will have its own account balance and its own account number. And that's good. That's what we'd want anyway. All right. So halfway down on page 86, defining methods. The methods of a class are essentially code routines that can be called upon to perform specific tasks within the context of the class. Methods come in two forms: type methods and instance methods. Type methods operate at the class level. They do things like creating a new instance of the class. Instance methods, on the other hand, operate on instances of the class. Instance methods are declared within the opening and closing curly braces of the class to which they belong. Type methods are declared in the same way as instance methods, with the exception that the declaration is preceded by the class keyword. So let's come in and let's create an instance method right here. And we'll call it display balance. And it won't have anything passed into it. Print All right, so what that should do then is when that display balance is called, it should show the user's account number and it should show the user's current account balance. In fact, let's be even a little bit more self-descriptive here. So account number and current account balance. Okay? Again, these are both. This is an instance method because it's not preceded by the keyword class. All right. When you design a bank account class, it might be useful to be able to call a method on the class itself, which will identify the maximum allowable balance that can be stored by the class. This would enable the application to identify whether the bank account class is suitable for storing details of a new customer without having to go through the process of first creating one. So long story short, we're going to create now a type method. And since it's a type method, it starts with the word class and then func get max balance. This is shown in your book on page 87. I want to make it a little bigger than what they have. We'll put $1 million. They put in 100,000. So far, all we've done is we've defined the blueprint for our class. In order to do something with a class, you need to create an instance of it. All right, so we will need to go in and create an instance of our class. So when you execute this code, an instance of the bank account class will be created and will be accessible via the account1 variable. Now it doesn't like something here. What? The use of the undeclared type. And I didn't think that would have to be inside of here. So I'm not sure if we can put that in here. I don't think it'll work if we put it in here. We can try it. But I think if we try putting it in here, we might get an error. Or maybe not. Yeah, I thought we would. Oh, well, there's one thing, is I said account, and I spelled it wrong. So let's try to bring it outside again and see what happens if we do that. All right. A class will need to perform some initialization at the point of creation. These tasks can be implemented by placing in a init method within the class, which is similar to a constructor that we've used in other languages. It would be useful to initialize the account number and the balance with values when a class is created. To achieve this, we can create an init method. And typically that init method will be up here before we have any of our instance methods. So we're going to type in init, and we'll put in number, which is of type int, and balance, which will be of type float. Now, as of right now, we're not going to, whoops, well, that wasn't good. We're not going to put in any checks in here. So we'll just say account number equals number and account balance equal balance. Okay, so we haven't done anything to check because you should have to put in, all right, an actual value, and that value, for example, for the balance, you would think would have to be positive. Well, notice now, okay, down here, technically, this is now wrong because now what should happen here is for our account, we should give it a number and we should give it a balance. So we should say here number, and what they put in the book is 1, 2, 3, 1, 2, 3, 1, 2, and a balance, which they put in at $400.54. Doesn't like something that I'm doing in here, but hopefully it'll resolve itself as we go on. So, when creating an existence of the class, it is now necessary to provide initialization values, which we've done. Conversely, we could have any cleanup that we wanted, so not only can we write an init, but if we want to, we can write what's called a dinit. Final code cleanup goes here. I don't know. Just going to put that in there like that. All right. All right. That takes us to page 89. Calling methods and accessing properties. It says here, now is probably a good time to recap what we've done so far in this chapter. We created a new Swift class named bank account. Within this new class, we declared some variables to contain the bank account number and the current balance. We have an initializer to display that current balance number or account number and balance information. We covered the steps necessary to create and initialize an instance of our new class. The next step is to learn how to call the instance methods. Well, you do that using a dot syntax. Now, I'm just going to try something here, and this might not work at all. Just wondering if I move that back in here, if that would get rid of this error message. And it has not. So, I wouldn't think that would belong in here. All right. So they talk about dot notation, and they mention as an example, I should be able to declare a variable here. I've still got that error, which I'm going to have to try to see if I can rectify. But I should be able to do this and say now var balance1 equal account1 dot account balance. All right, so balance 1 should be equal to our account balance, which we set up above to $400.54. We can also use it to set values. So maybe we just got our refund check for our taxes. So we can say account1 dot account balance equals 6789.98. And you notice that works as well. We can also say, for example, account 1 dot display balance. All right, so it doesn't like what we've done here. Expressions are not allowed at the top level, which probably means I'll get the same message here, yeah. Huh. I'm wondering if this is going to have to go into a separate file right here. And I'm just too proud to go back and actually look at the stuff that's in the book. I'm just trying to write it here myself. But my guess is if I grab all this stuff here and do try to move it into here, I don't think that's going to help any. See, I'm still getting the error messages. So let me finish this chapter because we only have a few pages to go. And after I do, then I'll go back and take a look and see how they did it in the actual book itself. All right? So, class properties, section 11.9 on the bottom of page 89. Yes, it's called stored and computed properties. And they say class properties in Swift fall into two categories: stored properties and calculated properties. Stored properties are those values that are contained within a constant or variable. Both the account name and number properties are stored properties. A calculated property is something that's derived in the form of a calculation or logic at the point at which the property is set or retrieved. Computed properties are implemented by creating getter and optional setter methods to perform calculations. So they've made some changes, and if we look up to the top of the next, or bottom of this page and top of the next page, you can see right here what they've added that's in bold. We're going to have fees and a balance less fees, so we're going to have that. All right, and we'll put that right up above our init. That's the way they show it in here at least. So let's go back into our code. And in here we'll put in let fees all right, so that's in there as $25. And you can see that stuff all went in there without a hitch. So the code above, as it says, adds a getter function that returns a computed property based on the current balance minus a fee amount. An optional setter could also be declared in much the same way to set the balance. So we could set a new balance in here is what they're saying. We could come in here and put in var balance less fees float and we want account balance equals new balance minus fees. And I goofed this up, so. And what I did not put in here, which I should have, in this balance less fees right here, this should have had a get before it with a curly. And curly. And this one should have had our balance less fees. This one should have had the get right here. remove this, add it down here, which will be good. So this right here, let's remove all this. This should say set new balance. Alright, so there's all the stuff. So the first thing that we put in here was this var balance less fees right here, colon float, get return account balance minus fees. That is a getter. It returns a computed property based on the current value, or current balance I should say, minus that set fee amount of $25. Then down below that we've got an optional setter that's declared in much the same way. So notice there's a set and there's a get. Much like we've had in other programming languages, the get is going to return a value of a certain kind. The set won't return anything, but it'll have something passed in. So the new setter takes a parameter, a floating point value from which it deducts that $25 fee value before assigning that to the current account balance. So the only thing that appears to be wrong right now still is this. We'll have to see if we can fix that. All right, pages 90 and 91. Programmers familiar with other object-oriented programming languages may be in the habit of prefixing references to properties with using self or this or something like that. And there are times when you are working in Swift, you'll have to put the word self with a period at the beginning. But with Swift, most of the time, it is no longer necessary to do that, because self is assumed to be the default for references to properties and methods. In fact, the Swift Programming Language Guide from Apple says, in practice, you don't need to write Swift in your code very often. So in most cases, the use of the word self is optional in the Swift programming language. There are still times when it is going to be necessary. One situation is when you're referencing a property or a method from within a closure expression. It's also going to be necessary to use self to resolve any ambiguity. When you pass in something, when you pass in a function parameter that's the same name as a class property. So for instance, when you saw here we used number and when we used balance. Had we said here account number right there or account balance right there, then we would have had to have said self.account number equals account number and self.account balance equals account balance. And that pretty much is it for Chapter 11. Be back with Chapter 12 in just a couple minutes.